Now for a third talk today, we have AJ and Avinash Dalvi. We have AJ, who is an executive director at Wells Fargo. He holds all 14 AWS certification and has served as an AWS ML community builder and co-organizes the AWS User Group Bangalore. His focus and experience lies in crafting scalable and efficient cloud solutions, as well as machine learning and data platforms for enterprises. Avinash is a senior staff engineer at Nushift Technologies and has 13 plus years of experience as a full stack developer. He also has worked as an architect for building solutions and products to help automation. He has experience of more than 4 years in e-commerce and finance domains. Their topic today will be on secure and scalable LLAMA models deployment in high regulation environments with AWS, EKS, and NVIDIA NIM. Thank you. Please, I welcome AJ and Avinash.
Thank you.
Thanks everyone. Okay. So, how many are working in an environment where you don't supposed to use any LLM model outside of your network? Anybody? Okay, this session is for you. And since I come from the financial background, we have a lot of constraints of running a large language model workload within on-premises. So, based on my best experience and the lessons learned, we want to share these insights with you. Go ahead. Okay.
Yeah, meanwhile, the slide is getting up here. So I'll continue with whatever the AJ has said, right? Like, so now, since morning, and we are talking about AI and prompt engineering, right? In this session, we'll a little bit give a kind of insight on different area where in AI itself, like I said, right, the LLM side, which will be kind of compliances, the scalabilities, what challenges are there. We are going to like give a insight on that part.
So we are not just running through the slides, we want to give a live demos. So we have some recorded videos as well as we have live demos. And whoever is interested in to know more about it and want to see how it is working, it is all running. So after the session, you can always feel free to reach out to me. I can speak a length and breadth of this, how it works, including what all the changes you have to make according to your environment. Okay.
Point. Okay, so we are going to talk about few things here. Like this is the agenda. Like we'll introduce what is the AI workload. How do we? What is the challenges will be there in an AI workload in regulatory environment, and then industry challenges. Then introduction to NVIDIA NIMs, and then we'll have a demo. If things work well, we'll walk through on a demo, and then the agent is going to walk through on like how do we make sure that and solve that the issues which is still is unresolved mode, he will walk through on that side. Right. So let's talk about and everyone know about it. The AI industry is AI is transforming our whole industry. Like everyone is building the different products, different ideas are coming out day-to-day basis, and the things are getting changed slowly. And in while it's doing it right, we have to make sure that we are adhered to the compliances, which has some regulatory bodies around that one, which will be kind of HIPAA or GDPR. And along with that, we have to make sure our cost also is not getting rocket science. Like that is also one of the challenges. And the same note, also our team who are building that AI, right? They also feel the empowerment with using those workload. They should not also feel like cumbersome. Okay, what I'm doing it and what kind of Docker like things are building it. So that is why I'm going to talk about like what are the different the challenges which we have, and what are the different solutions which AWS is providing, which enables us to make sure that those things are getting resolved. So the first thing is like compliance and security, where, as I said, we have to follow the regulatory things around that. So the HIPAA compliances to safeguard our patients' privacy, data sciences. So as you know, like there are finance and the healthcare system are very kind of critical system where every data are sensitive are there. Yes, along with that, other sectors also are sensitive, but those are very critical, sensitive, where customers or who users are getting the data, right? They might get panic around that if the data gets loose on that. And that's the reason, as per compliances, we have to make sure that our data gets safeguarded one. So for this one, like there are many options are available in AWS, like S3 Glue and AMR, AWS SageMaker Studio, which makes sure that these are the following in place, which adhere to the compliances side. And you can see that the AWS compliance program also provided security one, which has so many ISO certifications, compliances on that one. Now, next is the self-service data AI/ML capability. This is another next level of thing is there, where data is your key differentiation. As you are listening so many from the other speakers also, like data, we're talking about data, knowledge base, vector search, and everything is right. So that is why the year is like data is our key differentiation here. So as we empower the both technical and non-technical users, which will be have a data-driven decision, and that is why we have to keep that. The things, it's like it should be your models or your the AI things you are building it should be self-driven side. And for that, the AWS also has that similar kind of services, which I have talked about on the previous slide, the S3, Glue, EMR, AWS SageMaker Studio, Kinesis, Bedrock, the Elasticsearch, Aurora, Redshift, DataZone. The next part is like securing the robust and AI/ML environment. As along with the compliances and regulations, also we have to keep the environment secure side. So for that also, obviously our data is a critical thing for us, and if you can't secure it, we can't build things better. So that is why the critical for the protecting sensitive data and train and deploy those AI/ML model at a scale level also one of the challenges. So for that, we have options like the KMS, VPC, EKS, EC2 instances, serverless inference, batch job, which we will talk about that in detail. And obviously, the CI/CD monitoring part, which can be helpful, like to automate your model deployment with the version. As I said we have to make sure that our team also get empowered with that, what the workload we are managing. So they should not be a feel like the tiresome or maybe some the process is there. So that is why I require the CI/CD monitoring to make sure that the deployment is getting automated. For that, we have like SageMaker pipeline, Clarify, CloudWatch, Prometheus, and Grafana from the monitoring side. So these are the things which we have to talk about is like compliance and security, HIPAA 1, self-service data AML well, and secure and robust, and CI/CD monitor. So this kind of workload currently we're running into the regulatory environment, right? So yeah. So before, so this is the one. So before I talk about this one, right? Anyone can tell me like, or anyone running any AI workload in their production system and how much they are charging it? Roughly they can understand? Anyone has any data? Okay, good. But now you will get surprised with this data, right? So you can see here the highlighted part is, I'm not sure whether there is able to see, but a ChatGPT singles running on the per day is just charging around like $1 lakh. That is how the current data says that, and which is pretty high number. See, ChatGPT is still a big company, they can still manage it also. But the people who are building it, startup and all of this, right, it's very, very huge amount to manage it. And that is where the cost factors also come in a very crucial for in terms of the managing the AI. So there are a few industry challenges to manage the GPU resources. As you said, right, to run the AI workload, we need the GPU resources to make sure that these are getting performed and well-scaled one. So there are a few industry challenges, which is high cost and underutilized GPU resources, as I shown in a last slide, right? It was a high cost. But along with that also, some resources, you might use it, but some resources we might not use it, and still we are paying that cost for it, because still under it is not well architecture point of view. So that is why the reason we will have a underutilized utilization of GPU resources. Obviously, the scalability also one of the factors, and along with that, elasticity and the multi-tenant management. So it can support the multi-model, it can support the multi-tenancy, that it can run smoothly without hesitating the part. And again, I'm coming to the same point again, the compliance side, like performance, compliances, monitoring, and security requirement is also one of the biggest challenges which we have in the industry. To overcome this, I think you might have following the NVIDIA, all the announcement recently is happening around, and they are launching, many things are there, right? So similarly, they have launched recently called NVIDIA NIM, one microservice framework, which actually support the different kind of container and which runs on the inference engine. Which what is exactly inference engine is like? So if you have a kind of data which can plug into that, and it deduce the information from that only. So when you are running your own workload on a GPU, sometimes you have to build everything from the scratch, customize everything, and so that headache will be there. But the NVIDIA is providing a pre-built container kind of things, which you can see that if you go to the NIM, NVIDIA NIM website, this will have a list of all the pre-built containers, which you can just run it on your environment. It can be Dockerized, it can be just by using your code, and it can easily run it. So you can go to the website and see the list of the containers are available here, and it can easily use it. So how exactly work? Why it is beneficial in terms of and how it related to our problem, what we are talking about is, it has a pre-built container. So it helps us to make sure that we scaled very well also, because the pre-built container, it has no need to do much things about it. Your Docker container will be ready there. Your inference engine will be there already. The NVIDIA, the GPU also are well managed and what you can say, allocated the memory accordingly, whatever the process will be there. And then obviously it follow the industry standard API, support for the custom models, and specifically for the domain specific code will be there. So if you want to have a specific domain wise, it is available there. And it's, as I said, the optimized for inference engine. And inference engine is very much important in terms of the AI model workload side. So it has many things like standard APIs. These are the Triton inference servers there. Its cloud native stacks are there, and enterprise management, and it runs on a Kubernetes. So, and AJ is going to talk about like what is the unresolved issues are there, and how do we talk about this one. So there is a demo. It's running. So I will just talk about the demo. Just pause it. Pause. So demo is about like now which we have seen that there is a NVIDIA NIM website which was having some container. So what I did is I choose one kind of model there and selected as the Docker container. So I'm going to talk about that in demo is like running that particular model using the Docker container on the EC2 machine. So this demo will be like around that one. So what it does exactly, it just go to your EC2 machine, select your specific GPU one, and you can see that GPU, this is the AMA for the GPU, which has a GP6, yeah, correct. Yeah. Play.
You keep running.
Yeah. So I'll just keep everything, the basic settings only in, I will going to run the EC2 console. So it has a G6 2x large machines, which is for the compatible with the same AMI one. and I allocated the 120 GB3 because the container has a lot of the data when I was running. So when I was running, was like I initially give the 80 GB. It was exhausted the memory. Then I got to know that 120 is a sufficient memory to run out. Like so, you have to play around with that memory. Then you have to go to this website, select the any models. Then you can go to this tab where you will have a multiple language options and Docker containers option. You can choose your things. For this one, you have to get an API key. So you can go to the Get API key, then give your email address here, get your API key, then go to the EC2 console and check out your EC2 machine which is running around there, and just log into the EC2 console. And just to follow the instruction what is given in there, the NIM website one. So it's very simple one, like you have to just first Docker login with the tokens. So you can see the Docker login nvcr.io. It will ask for the tokens. So you'll copy the tokens value key here, and then copy the API key. Then we'll export some environment variables, that is the API key, along with the cache directory. Then we'll create a directory for the specific local cache, and then we're going to run the Docker container here with the specific details like 16 GB SSM size, and the API key as the environment variable passing it, and the port will be 8001, and this is the Docker container URL for it. So it will take a couple of minutes, like I just have the fast forward the videos, but it takes a lot of time to do that because it has almost 10 GB, 15 GB of each and every data. You can see in their console, like 1 GB, 23 GB, like that data is there. So now it's going to get started. It's saying that, okay, this is the one. So now we will test this API with our the curl request. So we'll replace the 00.00 to the actual IP address of your EC2 instance. So I'll just copy the EC2 instance IP address, and replace it here, and we'll try to run it. So when you're running it, so what's output is coming? Yeah. So what is that? We found an issue, so we got it to security and enable the specific port so that it will be easy to get. So 8000 port was not enabled, so I just added 8001, and the custom API is given anywhere, but it's not recommended in the production one. You can choose your specific IP address of the VPC group for making the changes. And then that's how you got the response back. Similarly, you can test it out this one. Now with this, I will hand over to the AJ, talk about our unresolved things.
So it's fun to deploy the model in your GPU, but is it solve your problem in enterprise? No, because running a single GPU for a single model is not going to solve the problem. And I am running in a single instance. If my requests are getting huge, if I'm having a lot of users, my cost is going to go high, and it is not going to scale automatically. Second thing, we did everything manually, okay, including provisioning the instance and configuring the port and allowing all. It's all fun, right? So is it a best practice? No. Okay. So anybody who is working in enterprise or even a startup company, the first thing we do is how to automate right from the day one. Even a 2 instance or 20 instance, we love to automate. So we are in a machine learning. We have to follow the MLOps practice, like how we are doing in a development. We have a DevOps practice. We have machine learning. We need to follow the machine learning practice. As well as if you are building a large language model, or even you are deploying the large language model, we need to follow the LLMOps practice. And we have to strictly deploy on your constrained VPC, constrained network, and write appropriate scaling. That's what I'm going to touch upon, the architecture. Then as much as I love to do the live demo, since it's all working, but I don't have a provision here, I also did the recording. I will go through it, and feel free to connect with me after the session. I can go in depth on it. Okay. So this is the architecture. So running a LLM on the EKS architecture. First, it's all done via Terraform. I can show you the code there and a demo. So it's all done via Terraform. And what that in the Terraform code is doing is, it is provisioning the EKS cluster first. Inside the EKS cluster, it will launch 2 normal CPU instance. What the CPU instances, it all have that management component. Then we are using a Carpenter for taking care of the scaling. Yes, we are using a horizontal pod autoscaler to make sure that if a lot of monitorings are coming, the Prometheus, all those pods which are running inside the EKS, which will do the autoscaling. At the same time, we are using a Carpenter autoscaler to do the GPU scaling. Why? Because we plan to do the scale 0 also. If the request comes, it will scale up also. So this is a high level. At the same time, the model, right? Whatever the model, we are seeing the safe.tensor.001, safe.002, the one he deployed. It is a huge file, okay? If you look at the container, it is almost comes around 13 gig, okay? And anyone who can answer, like we are talking about LLAMA model, 7B, 80 billion parameter. Let's take a simple example of a LLAMA 7 billion parameter. How much memory you needed? Any idea? Any rough calculation? Okay. See, while we are solutioning this one, we need to think about this architecture, what model we are going to use, whether the architecture of the model is using a transformer architecture or using any latest architecture like a mixture of experts, or you are using a later the recent architecture like a jumbo. Why does it matters? Because if anybody looked at the transformer paper, every token will compare with all the tokens we are giving. It's all run in a parallel. Each one will be stored in a KV. It's all called as a KV cache. So if it is 7 billion parameter, you just into 3, say almost we need a 21 gig parameter, 21 gig only for the cache. So we need to calculate all those things while you are provisioning. Currently we have selected the G6.2x launch because G5 is absolute. And there is a code over there from AWS, but it has some bug. So I went on and made some changes while we are running it. So we are running a LLAMA 3 8 billion parameter. And if there are more requests comes, the Carpenter autoscaler will look at the metrics and automatically scale. And all the model will be stored into the EFX. Okay, EFS is nothing but network file system. And backend they are using high throughput EFS. Why? The model will be same. The model will be binded as a mounted into any system it is loading. The model will be binded so that you no need to launch the model every time, which will take so much time. Okay, that's why they are using a EFS. Of course, we are taking from the NVIDIA NIM. When we are selecting the model in enterprise, we always look for a model card. It's not like I built a nice model from my laptop, I push it, big enterprise will do it. No, it's not going to happen. We look at the model card. The big enterprise we trusted on the LLAMA, it is open. It has a clear model card or what data it is trained upon. And we certify on NVIDIA because we have a NVIDIA which run in our data center. And we have our Kubernetes cluster running on top of it. And we are leveraging a NVIDIA to load the model from their certified environment, and it is optimized for the inference. And how many people had experience on deploying any model? Just normal machine learning model. How you deployed the model? Any idea? You use a serverless inference. Inference here too. Okay. So in a single container. Okay, so in a single container, how many model can run? Anybody tried multiple thing? Okay, that's where the Triton server from the NVIDIA come into the picture, where it just act like an API. You can have a 5, 6 model, but you need to follow the same structure, tree structure. You can deploy a LLAMA model, and you can deploy a LLAMA 3 model, LLAMA 13 billion parameter model. You can have multiple model, and you need to have a different endpoint for it. And it really works well. We have a huge benchmark if you are running a model by your own, and if your model backed by the NVIDIA Triton server, the cache and as well as the faster inference, it works very well and it scales very well. That's the reason we have choose the NVIDIA as the model. It's not like the NVIDIA, we given an enterprise, we taken it. It's really scalable. If you are interested to run any vision model and NLP model together also, you can do the Triton server. That's one more input on it, okay? So, I want to go through the quick demo. It's only 5 steps. But it take 1 hour, but I have done at least 20 times, so that I mastered on what am I doing. Please go on the demo. Okay, that's all the 5 steps. Create NVIDIA key and download the LLAMA model. That we have done it. Okay, I think I have done repetitive work. So you need to go here, create key, and it comes with only 12 months expiration date. So I created a key, and we need to give access to the NGC catalog, which is nothing but a NVIDIA model catalog. And then you can copy the key, but I'll delete it after this conversation. So we need to set up a Terraform. Already the code is here. I need to set up an environment variable because the Terraform look for the environment variable. If you want, there is a Terraform itself. They have variable.tf. You can go and add this key over there. But I prefer to have this because of the. Okay, yeah, I'm lazy. Okay, I don't even look at history. I increase my terminal memory and just go back and check it. Okay. So this is a model I have downloaded. I told you, right? This is almost 12.5 gig memory of the model. And download the NIM Docker image locally, because while we are running the EKS, it is upload to the ECR and then run it from the EKS. Okay. So run this environment variable. And you can do the git clone. I think I have mentioned the git clone also. If not, I will share you the git clone now. Okay. And after this, you need to run the Terraform. It's just a install.sh. Only thing is, it will take 45 to 50 minutes to set up the EKS separate VPC and have a EKS cluster. Then it will provision the 2 management node, which I'm talking about, EC2. Okay, this is the document I'm talking about. AWS GitHub.1. Okay, this is the one. You can always clone it, and it's really wonderful. You can try it. We have taken a different approach apart from what we have given this one, but this is a crux. Okay. See, this is a variable.tf you need to change. I have my VS Code. In that, I have my variable. I have made only few changes for this demo, but in enterprise we are doing it, you need to make a lot of changes, what model you needed, multiple model you needed, whether it is to be a distributed model deployment. If you are running a 70 billion parameter, it will not sit into the single GPU. So you need to enable the distributed model inference. So for that, there is some called tensor parallelism, and it will run on both the nodes. Okay. So I selected this model. So then I want to go to the Carpenter. I have given the resource. Okay, so this resource is G5 instance. It have multiple options like on demand and spot, all those things. You never get a spot G5 instance. It's on a sparsity. If you are running this, just run install.sh. It won't run because it will always look for a spot as a priority. So you can go and change as an on demand to make it run. So then you just run an install.sh and it will run, and you can do the go to this particular folder and then do the port forwarding. Nothing but I did a port forwarding and did a curl first. Okay, I just given an instruction so that you can take a snapshot at the end of this session. History. So port forward. Again, I'm lazy. I use a lens for it. Okay. So I just for the namesake, I am showing the command line. I go to the lens. And it will take 40 minutes, as I mentioned. So it will port forward, and then you can do the simple curl call testing. Okay, the model is running properly. Then you can launch. There is something called OpenUI. Anybody used OpenUI? It's a simple container where you can plug in multiple. It's like a ChatGPT kind of UI. It will look up. It's a free open source. You can plug into your large language model, and it comes with a nice chat history and everything. Okay. So here I'm running the curl call to the local because I port forwarded. I'm telling the model name, and I'm giving what is the tell me about ACD Kochi. Okay, it's given okay. I think I did some formatting error. Then I ran the default prompt. Okay, so see, this is why I don't like recording, because if it is a real live demo, I can show really exactly what you want to do. Okay, so I just ran the default one, okay. So you can see this one, and after that, I taken that model and run the UI. They have created a UI. They given a simple, you have a simple YAML file. It deploy the open UI into your same Kubernetes cluster, which run on a CPU. With that, you can launch that open UI, and I think I have shown that. Okay. So, okay. So this is a model. Okay, this is history. I have deployed the. Yeah, I want to show you some. Anybody who worked on a carpenter before? You heard about the node climb, node class. Okay, how it scale, all those things. So I played around with that. Okay, so we can scale up to 0. Also, I'm trying to scale down, but by default it runs as a 1. If you are giving us a 0, it is taking so much time to come up. If any given a prompt, it is giving error. Then I need to keep on warm up. Then it has taken almost 14 minutes to 15 minutes to come up. Okay. But in enterprise, you no need all the GPU to go down. We expect 5 to 6 GPU run all the time. So this is the pod. Okay, OpenWebAPI I'm talking about, right? I just did a port forwarding on this. Okay, so OpenWebAPI. So I did on a different port. Then I ran it, the OpenUI. This is the UI I'm talking about. It's open source. Even you no need a EKS. You can deploy on your local and plug into any of your model. If you're running a small model like a T5 model, you can plug in and you can test it out. So tell me about AWS Community Builder. So it give a nice response, and it is using a LLAMA 8 billion parameter that is tied to that. But backend it is using a local host 8000 to go to this request for solving. So that's all I want to show. I think I cannot fast forward. And check the monitoring. Okay, this config, because the core engine, right, the core concept here is run on this Carpenter. Okay, that's the interesting part. Okay, and we are running a Grafana and Prometheus on the same place, and we can, in enterprise, what we did is we are just running a Prometheus on it, sending to the, and the Grafana we are running separately, and we even taken out the Prometheus also outside of it and running this metrics. So this is a metrics. Okay, you need to reset the password to do this one. I think I have shown you this one. So you will get the, when come to the large language model, right, few metrics are very important. What is the first, how much time it taken to the first token to generate, and how much token it is generated, and what is the overall time to take whole completion. These are all the important metrics. Okay, so, and there is a one more option to do the performance testing. Anybody who are want to do the performance test of your application running on a GPU, there is something called GenA Perf, which is provided by the Triton server. So all you need to do is run that GenA server on a separate GPU. I don't have luxury, so I'm not able to run that. But I tested locally, but with my Mac, so we can run that one and call that HTTP localhost, which in turn pour forward and test it. Why we need it? We can understand how much time it is taking to the first token to generate, how much time it is taking all the tokens to be generated, all those testing you can do it. So this is the one I'm talking about, the Carpenter. So go here, this note here, it is, I edited this. Okay, so I think I edited and shown. Okay, so okay, I think that's all I want to show. I want to go back to the slide. This instances, I want to show these are the 3 instances running, the 2 management instance and 1 GPU instances. Okay, what I want to explain? I think I want to explain the Grafana dashboard. That's why I'm searching that time. Okay. So that's all for the session. I want to quick back to the slider. Okay. So, okay, here we were doing only inference. Okay. How many people have a requirement to train the model from the scratch? Anybody had the requirement anytime? Okay, fine tune the model. Currently we are using a Bedrock, and Bedrock has an easy UI where we just keep if it is a labeled data sets, we can keep for the fine tuning, we keep it in S3 and fine tune the model. That is very simple. Yeah, I take 3 to 5 hours, and we can have the fine-tune model. But in enterprise, we don't have the luxury. We need to use a similar kind of infrastructure to train the model from the scratch. That's where we want to use something called, can you go to the next slide, please? Okay. Oh, sorry, I can do. Sorry. Okay, this is what we can do. They have something called hyperpod. You can use a hyperpod, and what the hyperpod will do is the same EKS cluster, but there is some concept called capacity ML block, where if you have a plan to train the model by Saturday morning to Sunday night, you can go block your GPU instance, and it will come here, and it automatically provision the cluster for you in a hyperpod, because running a parallel cluster, running a HPC cluster, setting up from the scratch, connecting all the GPU to run on your own is a big challenges. And you can go and check on some white papers like a Bloomberg GPT. They ran the model half a way, and one of the node got failure, and the cost, all the time they have spent to train the model went lost, because they are not able, they don't understand the concept of model checkpointing. Using this hyperpod, every time you train the model, the checkpoint will happen. Of course, it will use something called FSX and store back to the S3. And anytime you want to train the model, if you want to replay the model, if any node goes down, the hyperpod will take care of it. Of course, it is using the Carpenter at the back end. Of course, it is using the EKS of the auto scaling features and all the scalability features to train the model using the same architecture. You can do the fine-tune model, and you can use training the model from the scratch using this architecture. It is a newly announced SageMaker hyperpod on EKS. Anybody who interested, feel free to check it out. And I'm testing by myself. If anybody want to try it out, connect with me. I can share my experience learned. It is not easily straightforward as they said, but you can do it. And they come with a separate CLI for hyperpod CLI, where if you have multiple 10 NVIDIA nodes are running, you can check it out. You can log into one NVIDIA node and check it. And if you want to train the big model, how much checkpoint is happening, where the model is happening, how it is distributed, all those monitoring can be done from here. This is about the training the model. So we have seen inference, we have seen how to train the model and fine tune the model in the enterprise within your local environment with leveraging the power of EKS. That's all from my side. And takeaway, you no need to high cost. GPU is very scarcity, so you can run at the optimal price, and it is a multi-user management. You can have a separate namespace and with the proper pod management, quota limits, you can have multiple people running multiple models on the same environment, and with a Terraform and deployment architecture, proper follow the MLOps architecture, and of course it's run on a secured environment. That's all from me, and thanks for your time. Okay, thanks for staying. I know the lunch is ready, but still you are straight. I'm happy to open and take questions.
Questions?
Since it was like high cost, that's the reason why we are moving on to this. What would be the average cost for the training or for a basic model?
See, my clock is ticking. Every 1 hour I'm spending time. Okay, it's $2 per GPU. Okay, that's my takeaway. Okay.
Yeah. So that's what. So that is like. So when you talk about like
in an enterprise, you won't feel it, because we will run. Sometimes we run on premises, so we no need to worry about hourly cost. It's all about one-time installation.
Yeah. Yeah, but still, on an average, it comes to like, even if you're running an inference, it comes to like $3,000 to $4,000 per month, right?
Yes.
At a bare minimum. I'm telling about when you use just one node. And if you're going for a Kubernetes, I don't think it's stopping anywhere near to $5,000 per month.
It depends on the volume. Imagine if you have 50,000 users, and 50,000 users, you are giving a API for the OpenAI APIs to them, and everybody hitting left and right. Think about the money, okay?
Yeah. Okay, so that's imaginable. But the thing is that what is the difference on the compliance problems that the Bedrock has when you want to move to a model like this? Say for example, these models like Sonnet, which we won't get, which we cannot, where you have you can leverage bigger models like the LLAMA 90 billion. You cannot just simply put on a GPU is not available. The basic GPU or the instance GPU size maybe like 80 GB, which is the maximum. What is the compliance problem that the Bedrock has?
Okay, Bedrock is fine. And a lot of companies have a strict convention. You should not use the management service. And whatever the environment we are using.
That's why I wanted to ask. So why is it what is the problem behind that? So what is the compliance that, say for example, I'm running an insurance or a medical domain and I am in the AWS space itself. Can't I use Bedrock? Because Bedrock claims to have that it runs within the VPC itself and no data is
No. Bedrock don't run on the VPC. We have a VPC endpoint where your call to the Bedrock will go within the VPC. It will not go over the wire.
Correct.
But
it's a
Bedrock,
private link, right?
Yeah, private
Bedrock,
link.
It is a private link,
Yes.
right? So they claim that the data doesn't even go into the outer internet at all. It doesn't travel. So in that case also still is it breaking the compliance issue?
Yes, we have something called, I told you, right? We want the model to be open and we want to know it's a model code to be understand what corpus of the data is trained upon. We want to make sure all the inferences which we are sending has to be monitored. All the three can be done by a Bedrock, but we don't want to use any of the managed services. And the same environment, I'm explaining here, we are not running on premises. We are not running on EKS. We are running on premises. In enterprise, we run on premises.
Yeah.
Okay.
So then there is a reason why you use the LLAMA model is only because of that specific
Yes,
reason?
it's open.
That's the only.
It's open. Okay.
Then how do you then? What is the clause over there? See, because when licensing, especially when it comes to Llama, what is the license that they provide? They provide a.
They have something called 700 million user. Any company has a 700 million users should not do it. They have clearly targeting my competitors. Please don't use it. Okay. And big enterprises, they have their own certification license vetted with the Llama. And why Llama? It's not only Llama. They have multiple models in enterprise we can use. I just to take an example of Llama for the sake of better understanding. And we are finding rather than running inference on the cloud and rather than having API based to the OpenAI or something, we prefer this is more secured in a compliance environment, because even if you're giving a thumbs up, thumbs down, right? It's like we are sending a signal to the provider, okay? And we have a complete trust on Bedrock. It works well. But when come to the production workload, particularly if you are running a mission critical internal workload, we prefer to use the compliant environment, leveraging the stack. And the same stack, we want to use it for a training as well as deployment. So the EKS cluster remains same. Only the components will change apart, okay? And we are looking for a multi-tenant also.
Okay. Also, one more thing is that how is like cloud to cloud? Does that also?
No. Cloud to cloud, forget about it, okay? That's ingress cost will eat out your whole packet. Cloud to cloud, it's.
But does that also break the compliance thing? Like say for
See,
example,
cloud to cloud, why do we need a cloud to cloud from there? We prefer the same infrastructure, we deploy in another cloud. It can be AKS or it can be in a GKE also. We can run the same workload on any environment. So that if the Terraform code is not going to change, all we need to do is make a changes on your modules, on whether the VPC, all those things we need to change. And we follow the same practices and deploy that. And your Carpenter is not going to change. Carpenter can run on anywhere, okay? Because Carpenter is open source. Yeah, it's completely done by AWS from the ground up, but it run on anywhere.
Thank you.
Thank you. Any questions? Anyone who love to see from my laptop how it's working?
One question on the SLMs, right? So in enterprise world, where we use the specific use cases, so over there the LLM might not be that useful. I mean, it's not even need that big workloads, right? So why don't we, talk more about SLMs and make it more popular so that we don't need this large workload, because many organization doesn't have, especially the small scale organization, they don't have the on-premise and they don't have this much server to set up. So we can still use our SLMs to make many use cases possible, right? So
see, most of the SLMs are distill model. You guys agree on, right? It's all distill model. Parent model will be there, it trained on distill model. Currently, we deployed a Llama 8B, which is on a single GPU. And we are okay with any SLM with tick on all the boxes. It should be open. It need to train on all the corpus of the data, which they tell upon. But the challenge is, if you are using a distill model, we don't know what response the teacher model given and what is how this model data was transferred on. Okay, but if you look at the Llama model go on corpus, it is not a student model. It is completely trained upon the open data sets. Okay, you can see WebMed they have used, Wikipedia they have used those data sets. Okay, And when come to the distill model, you have to be carefully use it, okay, because we don't know what teacher model they used. If they have declared what teacher model they have used, then that SLM will be better to use it. If the LLAMA model we are using nowadays, the LLAMA teacher model, distill model is coming, right? That is okay for that is okay in enterprise.
Do the basic experiment on SLM and then prove yourself that your use case works. Then use it.
Yes, yes. See, everything goes on the data. The data is your differentiator. Okay. Even if you are using the LLAMA model, most of the use cases will run around a RAG. Okay. And we have a strict one. It should not hallucinate. Okay. And we have a proper guardrail. If anybody heard about the LLAMA guard. LLAMA guard, okay. It's nothing but another large language model. So any inference you get, any request you are giving, it will validate your response. Like how we have a guardrail, Amazon guardrail we are talking about the morning, right? It has all the profanity filter, all your content filter, everything. Same way, it will be just like a YAML file, you will declare everything. And when you are giving a request, it will go to the LLAMA guard first, and it will be restricting whatever the profanity content. Then it will go to the large language model and further response. Why am I touching upon for the LLAMA guard here is, even we have a RAG, we will apply the LLAMA guard, make sure that it does not hallucinate, and make sure that it is not giving any unresponse. Okay, so in enterprise comes to it, it need to be completely guardrailed.
Thank you.
Thank you.
Any other questions? Then I would like to invite Sayana and Tinsy on stage to hand over a token of appreciation. So thank you so much for the amazing talk. It was the last one for our morning session. Everyone, if you could please leave through the doors for lunch. It is right next to the registration room. Then we'll hope to see you in the afternoon session.